Have you ever wondered how to find the derivative of an inverse function at a specific point? It's a question that can seem daunting, but with the right approach, it's a journey of discovery that becomes quite straightforward. You start with a function, let's say fx, and its inverse, f circumflex 1, x. You specify a point x equals b, where the derivative of the inverse function needs to be found. The formula you'll use is b equals sine 1 per f circumflex 1, b. Now what does this formula mean? f circumflex 1, b, is the derivative of the original function f, evaluated at the point f circumflex 1, b. This point is the corresponding point in the original function's domain that maps to b in the inverse function. The one in the formula acts as a scaling factor, flipping the slope of the derivative due to the inverse relationship between the functions. In simpler terms, the derivative of the inverse function at a point is the reciprocal of the derivative of the original function evaluated at the corresponding point in the original function's domain. Applying this formula requires a few steps. First, find the expression for the inverse function f circumflex 1, x, by swapping the roles of x and y in fx and solving for y. Next, differentiate both sides of the equation fx equals sine y to find the expression for fy. Substitute f circumflex 1, b, for y in the expression for fy. The reciprocal of the result is the derivative of the inverse function at the point x equals sine b. For instance, consider the function fx equals sine x squared. Its inverse is f circumflex 1 x equals sine squared x. The derivative of fx is fx equals sine 2x. To find the derivative of the inverse function at x equals sine 4, substitute f circumflex 1, 4, for x in the expression for x, giving f2 equals sine 2 times 2 equals 4. The reciprocal of 4 is 1 4, so the derivative of the inverse function at x equals sine 4 is 1 4. So, by following these steps and understanding the formula, you can find the derivative of any inverse function at a specific point. It's a journey that's not only interesting but also opens up new perspectives on how functions and their inverses interact.